Hello everyone! In this episode, we will be demonstrating the Ralston method. So here we have the formulas for the Ralston method, also known as the second order Runge-Kutta. So here we have the y sub n plus 1 is equal to y sub n plus 1/3 of k1 plus 2/3 of k2 times h. So the formulas for k1 and k2 are f of x sub 0 and y sub 0. It's pretty familiar from the previous steps, from the previous methods, but the k2 is different. So we have the f of x sub 0 plus 3/4 of times h and y sub 0 plus 3/4 of k sub 1 over h. So yeah, we're going to use these formulas. So here we have the y prime is equal to x squared plus 3y equation. We have the initial value for the y as 1, and we have a step size of 1. So in the first iteration, we have this. So y sub 1 is equal to y sub 0 plus 1/3 k1 plus 2/3 of k2, and then h. So substituting the values, we will be finding that we don't have the value for k1 and k2 yet. So we'll be doing these solutions. So here we are. K1 is equal to 0 squared. Simply substituting the values of the x sub 0 and the y sub 0 to the x and y variables in the equation. And therefore we'll be having the answer 3. At the K2, we have this function of 0 plus 3/4 times 1. So the 1 is step size. Then this is the initial value of x, and on the other hand we have this 1 plus 3/4 times 3 times 1, where 3 is the value of k1 step size, then the initial value of y. So we now have this 3/4 and 13/4, and substituting these values into this equation, we will be having k2 is equal to 165 over 16. So putting these two values into our main equation or formula, we will be getting the answer 71 over 8, or nearly 8.875 for the y sub 1 at our first iteration. We could go to more points by repeating the steps, just repeating. You could do it by yourself. So at this point, I think we have just solved it.